Hello everyone, today is day 14 of solving a LeetCode problem every day. So today I'm going to solve valid parentheses. So given a string S containing just the characters, these following characters right here, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So in this case, it is true because we have a matching closing bracket and it's in the right order. In this case, we also have true for the same reasons. This case, we have false because the closing bracket doesn't match the open one. And in this case, we have true because everything matches up. So let's get straight into the solution. Cool, so up here I've defined two strings, S and S2, and these are going to be both of our test cases. We're going to begin our solution by initializing a stack. What we're then going to do is loop through these strings and add each character to the stack. So for string S, we're going to begin by adding in an open parentheses. Then we can see here that our next character, is a closing parentheses. So what we're going to do is we're going to pop the item off the top of the stack. So we're going to say top is equal to an open parentheses, and we see that this matches up with its closing parentheses, so we can continue. We're then gonna add an open bracket to the stack. Next, we add an open parentheses. Now our next input character is a closing parentheses, so we pop the open parentheses off the stack, and we see that this matches with the closing parentheses, so we can continue. Now finally, our last input character is a closed bracket, so what we're gonna do is pop this opening bracket, and we see that this matches with the last closing bracket. So now our stack is empty, so we can return true, and we know that this string is valid. Now I'm going to do the same thing but with string 2. So first thing we do is add the open parentheses to the stack. We see that our next input character is a closing parentheses, so we pop the open parentheses, and now this matches up with the closing parentheses, so we can continue. We next add the open bracket to the stack. We add the open parentheses to the stack. Now we see that the next character is a closing bracket, so we're going to pop the top of the stack off. But now we see that the closing bracket doesn't match up to the open parentheses. So in this case, we can return false. So this was a quick high-level overview of the solution, but let's get straight into coding it. So the very first thing we're going to do is initialize the stack. Once we do that, we're going to loop through each character in the string. Our first three conditions are going to check for opening delimiters. So if we get an open parentheses, we add that to the stack. If we get an open curly brace, we're going to add that to the stack. An open bracket, we add that to the stack. So we're then going to have an else statement, and the first thing we want to do is check if the length of the stack is equal to 0, and in that case we're going to return false. Now the reason why we check this is because if the length of the stack is empty and we try to pop something off the stack, we'd get an error in that case. So this is just to make sure we don't get that error. Now our next three conditions here check to see if the character is one of the closing delimiters. So in that case, we'd pop the top off the stack and make sure that it matches up to the closing delimiter. And if it does not, we'd return false. Now finally, we return if the length of the stack is equal to 0. So we do this because there may be a case where the stack is not empty, and if the stack isn't empty, that means we haven't matched up all the delimiters. So we'd want to return false in that case. But if it is empty, we want to return true. The time complexity of this algorithm is going to be O of n, and the reason why it's O of n is because we're just processing each character just a single time. Now as for space complexity, it's also going to be an O of n, because in worst case, the stack's going to contain n elements.